Welcome to our first episode of Altruistic AI Agents. We are building AI agents to help real people do real important work. On that note, I'm so happy to introduce my dear bro, Vivek. Vivek, how are you, sir? Good to see you. Thank you for joining us.
Thanks so much for having me. Yeah, I'm really excited to dive into all this.
I'm so excited, Vivek, because I think this agent is a pretty cool tool, and I'm hoping it's going to be high impact.
Yeah, absolutely. My main lab group, we're conducting research at the Cedars-Sinai Medical Center in LA and at Dartmouth College. We've been focused on doing spatial transcriptomics research. Really exciting work, but it's been quite challenging as well, as you can imagine, working with huge volumes of data, requiring input from expertise spanning multiple domains throughout mathematics, chemistry, biology, medicine, et cetera. There's still so much work to be done in the space. And I think a lot of the systems that you're trying to build here are going to go a long ways towards contributing not just to this type of research in spatial transcriptomics and cancer research, but in all other domains of medicine and data science.
Man, fingers crossed. I'm so hopeful that this will be a new moment for so many fields. The level of precision that you're talking about, that we can, take a look and see what these exact cells are saying to each other. It's so remarkable. I'm curious if I'm kind of interpreting this in the right way. I sort of myself have a personal mission against cancer because when I was young, someone very close to me went through cancer and didn't survive, and so had an incredible loss in my own life, but also saw what that person went through during the treatment, and they had to go through chemotherapy, right, which is essentially poisoning the whole body to some degree so that you can poison the tumor more. And it's always just occurred to me that that is such a like carpet bombing approach. Like it's so like a blunt force object to the whole biology. And it kind of sounds like what you're saying is you guys are seeing things on a level where you're not working with a sledgehammer, you're working with a scalpel. Is that true?
That's exactly what we're doing. We're trying to go away from some of the older paradigms, which had a more generalized, untargeted approach, to now more targeted precision medicine-based approaches, so that you're not just carpet bombing the entire system and damaging all of your healthy cells in the process.
So excited. And I think on that note, and with that sense of mission, we can jump in, Vivek, to showing off the system we built. But yeah, when it comes to like this idea of trying to work with a scalpel instead of a sledgehammer, and then the scalpel being these little particles, Vivek, what is it like to kind of stay on top of all the different tools that you could use, all of the latest research? How does that fit into your flow? And is that something, that could be helpful to get an AI's backup for?
Yeah, this is one area where we can use all the help that we can get. It's actually impossible to keep up with all of the research that's being published every day. We have thousands of papers coming out every day. Any type of AI-assisted approach to help parse through all the very potentially relevant research papers to our work, help us distill and filter down what would be absolutely essential to our work, a huge critical benefit to our entire workflow. And it would affect every facet of our work.
If there's even a second in a day, I could get back to you so you can focus on patients, I would be a very happy man. So let's get it in action. This is a AI agent. It is a 4-part sequential agent. As you can see, there are 4 blocks here. Each of those is a different AI. This system you might think of as an AI team, but we call it an agent. This pipeline is intended to go from paper to protein, but really it's more than that. We're not just wanting to find the particles in these papers, but produce fully operational reports that have the PDB file, have all the actionable information. And then coming into these kind of research projects, Vivek, you'll have to tell me if it ever feels this way to you. But you know, in those movies where they're going for the murderer, and then they put up the big bulletin board, and they put all the pictures on the bulletin board, and you're connecting them with yarn, and trying to see how the suspects fit together. I find that biology is so like that. That you have a tumor with a very complex microenvironment with all kinds of particles, proteins, antibodies floating around. And then it is kind of like a thing. You have to see, who are my suspects and what do I know about them. So yeah, getting from what could be tens of thousands of pages of papers down to like maybe 100 reports on particles that could be useful or could be interesting is what we're trying to do here. Vivek, we did work closely with you and we kind of asked you to break down your process here because I think that's one of the things about AI agents that we're so excited to share in these shows, that really the deep knowledge that's needed to build an AI agent is in a human mind, telling the components what they need to do, tuning them, getting them to operate properly and follow the pattern that the human understands is like the key value. With this first node, the idea would be papers get fed into this first node here, the paper search agent. What does that node do?
So for ingesting the papers, first we would start with the broad strokes. So we'll get the overall title, extract some information from the abstract of the paper, which is usually how we would approach our literature reviews anyways. So I think, yeah, this is a huge top-down macro to micro approach. This way we're able to first assess which papers topic-wise and major component-wise are most relevant to the specific set of hypotheses that we're studying.
Yeah, and so you can see right here we have our prompt. You are an expert oncology researcher who's helping to select scientific papers to be used as a basis for new immunotherapy design and discovery. You'll be given the title of a paper, the abstract, and you need to decide on a scale of 1 to 100 how likely is that paper to be relevant to the target. This model, and we selected here DeepSeek 70 billion. It's an incredibly powerful open source model that is comparable to the best models from OpenAI or Anthropic. And in this case, we selected the 70 billion parameter model. The selection of the model is one of the key engineering design questions. It's very interesting because what you kind of want is a model that is smart enough to perform the task, but not too smart, because kind of the smarter a model is beyond the behavior that's required, the more trouble it can cause, the more hallucinations it can cause, the more effort needed to tune the model. So yeah, it's a very interesting and very new set of design questions that kind of intersect this machine learning engineering with this kind of human operational thinking. So this node will be fed a paper or a family of papers, and it will select a subset of those papers that seem relevant, and then those will be passed to the paper reader agent. What does this one do, Vivek? Like when you found a paper that seems like it's a good fit for what you're doing, how do you kind of go through that paper and find the important parts?
I'll take a look at the major sections of the paper that seem to have the very potentially useful and relevant molecules, for example, that are related to the mechanism or the hypothesis that we're studying. And here, yeah, it looks like we're giving it a score on a scale of 1 to 100 for how likely a particular paragraph is to contain the description or information related to, say, our immunotherapy related molecule of interest.
We remember our inspiration, Vivek at his coffee table and a big stack of papers. Pick a paper, go through the paper, check off paragraphs. We got this machine learning system doing the same thing. Papers passed into here, paragraph by paragraph. Paragraphs are rated 0 to 100 on potential relevancy. Papers that score above a threshold passed on to the next node. Particularly interesting, though, a paper can have many paragraphs, and we may be working with many papers. So we may have many paragraphs. And so we have selected here the Falcon 3 7 billion model. This is my current favorite small language model because it has a number of what are called state space features. So for tuning this smaller model to have very specific behavior, you get a lot more bang for your buck with Falcon 7B than most other small models. And with the design imperative being the smallest model that can do what you want and no bigger. For this one, where we have an enormous number of paragraphs to read, but it's not too complex a question we're asking, the small model is just perfect. It's just exactly these kind of questions of model selection and engineering that are so fun to work on and look at together. But now we get to the big exciting node, this third node, and this is the actual oncology agent. This one is going to be fed paragraphs that have been selected to be of relevance. And then look at the model. So we're doing the full-blown 671 billion DeepSeek model. This takes quite a few GPUs to run and also allows us to do pretty sophisticated tuning. This is the model, Vivek, that we're very excited to get you talking to get you evaluating the results of this model, helping us teach this model how to do its job a little better. This one's job is to take a paragraph that contains a potential protein or antibody of interest and then actually structure it into a lab report. So if you think about chasing down that murder suspect, that's the picture picture you're going to put up on the board start to connect to the other dots. And yeah, it's kind of an interesting thing too. I have to say I'm so excited to start doing human feedback tuning of this model with you. But I'm a little curious too, just to get your sort of reaction to that idea. Like, how do you feel about kind of transferring some of your wisdom?
I think that's absolutely the right way to go. It'd be hugely impactful. As we're talking about this, I'm starting to get some more ideas for other important aspects of this approach and system that I think could be great to integrate. For example, one huge problem that this approach can really help solve is, say there's a specific breast cancer target, say like a HER2 target that I want to study related to the efficacy of trastuzumab or Herceptin on a HER2 positive breast cancer. Then I find a paper that I think has quite a relevant and intriguing study that generated data that would be helpful for us to reference or supplement with our own data. Oftentimes, when we dig into these papers, we'll see that sometimes it can be quite difficult or quite laborious to find if the paper used data that would be relevant or applicable to be able to fit into our pipeline to supplement our approach. It can be quite challenging to do this sometimes. So this type of system that can help generate a thorough lab report for each paper that it goes through and then generate a lot of useful files, useful data points that we can collate into a structured report for each paper that we're looking at, I think is hugely helpful. And it helps solve one of the biggest problems that I've personally run into in my research career.
Your reaction there is so exciting because I have to say for me too, when I see these things, it gets me excited about, what other things do I do with my mind that I could do with this mind, or that I could teach one of these new minds to do or learn how to do. And then also think that is very important to remember that we're about to go through a transition where a lot of stuff that humans used to do will be done by these kind of agents. I think it is very important to remember that you truly are contributing something enormous to this project by helping us to see how your thoughts fit together, by helping us look at the thoughts of this mind and kind of adjust them. And so I'm hoping in addition to building a tool that will be helpful in your practice, we can kind of start to tell that story of like the future we can build if we kind of work together to build these things and find a way to do it that includes us. We can be stakeholders and we can continue to make sure that the things we do in our mind are playing out in a positive way. Very much looking forward to us doing some RLHF of this big guy here. Final node and final step of our journey. Once this report has been generated, we actually do want to create what is called a PDB file. Here's the protein designer agent. It is fed this big report that includes a bunch of scientific details, number of engineering and medical details, and then also like a textual description of the protein, which sounds kind of weird, but it turns out there's also an AI that you can describe a protein to verbally and it will create the 3D structure of the protein. It does really well. It's magic, Vivek. I don't know how it does it. But yeah, that's the final model that this report is fed to. It basically just grabs that text description of the protein, generates the 3D file that you can see here in the result, puts it back in the report. Once again, Vivek will be doing a bunch of testing, a bunch of iteration, a bunch of tuning, but I'm just so excited that, we're going to be dumping a bunch of papers in one end and getting you out a bunch of like operationalized molecules that you can kind of start studying and getting moving towards a patient impact. I'm really so excited to, continue developing this model with you and kind of telling the story about the important human role that there is to play in the development of AI agents and the positive impact that AI agents can have on society. Our next pilot will be working with someone at FEMA and building a system that they can use to develop logistical plans coming into a new city. So I really say that with a motivation of hoping you'll think of something you want to do with an agent and maybe you'll reach out to us. And then one final note, do want to extend enormous gratitude to Lilypad for both supporting this work by supporting my research group, also by helping us with the compute. Lilypad is a decentralized compute network. Think Uber for GPUs. If you have a lazy GPU that isn't doing nothing when you ain't gaming, you can put it on the network and then it's going to start analyzing onco data for Vivek or potentially other things. And then you can collect remuneration for the work that your GPU does. And with this topology, Vivek, actually, we had a very particular challenge that was very incredible. Lilypad was able to help us with. The second agent here, the paper reader agent, before we added that one to the topology, the oncology agent was kind of sucking. And the reason why was we were giving it a whole paper, and it was kind of pushing the context window. So these models kind of have a memory, and if you fill the memory too much, they get a little tongue tied. I get the same thing though, to be honest. So no aspersions to DeepSeek, but that was what we found. Is DeepSeek just needed a little assistant. It needed someone to kind of take the big papers and break them down into bite-sized pieces. It turns out that that kind of very large-scale batch inference is just what the Lilypad network is designed to handle. So for anyone building agents in any framework, when you find one of these nodes, and these kind of nodes, these kind of highly parallel batch small language model inference jobs, very common. It's very often the case that when you're tasking a big model with something, you realize it's not quite within the capabilities of the model. But if you set up a pre-processing step with a smaller model, you can make it work. For anyone designing agents who need somewhere to send your small language model batch jobs, go check out Lilypad Technologies. In coming weeks, we'll be releasing future episodes where we're using compute from the Lilypad network to build altruistic AI agents to have a positive impact on society. Any kind of final thoughts other than let's keep building this thing and then get it doing work?
Through this convo, in addition to many others that we've had, it just gets my mind going with some new ideas. And like you mentioned, these distilled smaller LLM models themselves have their own utility and profound elements. Just kind of using them in isolation, it opens up this huge new field or setting to perform all of this inference locally in smaller devices with more constrained compute resources. But when translating and applying to solve some of these big problems with these agentic systems, these smaller distilled models become even more critical to helping the larger components function properly. It just gets me quite curious about studying some more of the emergent effects of each different type of model and trying to see, how we can fine tune and play around with the thresholds at which larger and smaller models perform best. So I think all of the work here will go a long ways towards research in that whole domain as well. Just to say lastly, these types of systems, humans working closely with these AI systems, one of the most profound things, at least to me personally, has been that I've seen these systems allow people to think more creatively. That's been one of the most magical parts in working closely with these systems and helping to not only develop them and also talking to them and learning from them. Huge congratulations to you and the team on all the work. This is really inspiring, and I can't wait to do a whole lot more with you guys.
Oh man, well on that note, I'm looking forward to it right now. I'm imagining us at a Science Sunday with a cup of coffee and a bunch of screens. And it really is so exciting. And as a person who really kind of loves the intersection of data science and kind of humanity, I think this is such a beautiful process that we're going to be going through. We can try different models for each of these nodes. We can change the prompts. Each of these models has tons of parameters. The configuration space of the system is large, and the process of going through it and leveraging experts to tune it is virgin field. This is a totally new thing that we're all trying to figure out how to do together. And the sooner we do it, the sooner we can start having impact in all these different areas. So Vivek, thank you for joining. For the Altruistic AI Agents team, thank you guys for helping us get this first pilot episode on the books. And yeah, moving forward, please reach out to build an agent to support the energy and to see if we can kind of move the world in a direction where the story will be that humans used to have a lot of trouble when we were on our own, but just like this DeepSeek 671 billion model, when we got the support we needed from our AI friends, we were able to start handling things in a totally different way, a better way. And I don't think we should take for granted that that's the future we're headed towards. But I, can't help but believe as a stupid optimist that if we, work together, we can lean on the wheel and kind of move the car in that direction. So anyway, thank you guys so much for joining us, and catch you next time on Altruistic AI Agents.